Hi everybody, so this is the video for lesson 7. We're going to be talking about secants and tangents. So to start off with that, we're first going to do this opening exercise, which asks us to do 3 things. We're going to sketch a line that intersects the circle once, one that crosses it twice, and then 3 times. So on your own, try and do that. See if you can do those. Remember that a line, though, needs to be a straight line. Okay, so when we're talking about geometry, sometimes when we say, oh, okay, this is a line, but it's not actually a line. Lines need to go on forever in both directions, opposite each other. It needs to be a straight line. So when you do these, it's got to be a straight line. So if we were to try this, if we were going to have it intersect the circle once, a lot of you guys might have done something like this, where it just crosses one time there. But remember, it needs to go on forever in both directions. So if you continued this, it would actually cross twice. So that's not going to be crossing once. That's going to be the one that crosses it twice. If we were going to cross once, it would have to look like this. It would just go through one point, and it would just touch the circle and go past it. Okay, just touching on one point right there. Now, if we were going to try and do 3 times, we're not going to be able to do that, right? There's no line that you can draw anywhere on here that's going to go through the circle 3 times. So that one's not possible. Okay, because it has to be a straight line, you can't do this last piece here. Now, these 2 different lines that I made up here have names. So the first one that we're going to talk about is a secant line. So that's when you cross twice. So that is like this. Straight line, both directions, on and on forever. That is a secant line. And it's going to always cross in 2 points. And this piece in the middle here, that is a chord. Okay, that's something that we talked about in a previous lesson. Okay, so that's when it goes through twice. And then a tangent line just touches it once. Oops, there we go. Just touches the circle at exactly 1 point. So it could be any 1 point on this circle, and it just touches it just on the side there. Okay? Now, there's some rules that go along with these. Because if we have a picture like this one down here, we've got a tangent line where it only touches the circle once, and we have a secant line that goes through the circle twice. And if you have an angle formed by those 2 lines, then that means that it will be equal to half of the measure of the intercepted arc. So it's going to be really similar to inscribed angles. Okay, we did that a couple lessons ago, and I'll show you exactly what I mean. So we've got this angle formed by the 2 lines. That is angle X. Okay, that's the whole thing. And the arc is going to be everything from one side of the lines all the way to the other. Okay, so that's the arc that they're talking about. So it's telling us that Y is 320. So this is 320. And that is our intercepted arc. Okay, and then the angle made by the chord and tangent, that is X. Okay, so our angle, which is X, is going to be half of the measure of the intercepted arc. Okay, so that's going to be half of the arc. Okay, so since the angle is half the arc, that means that x is going to be half of the measure of the arc. So half of 320 is 160. So that's our answer. That's what angle x is. It's 160 degrees. And that's really close to what the intercepted arc, or the inscribed angle, I mean. The inscribed angle formula was when we had a circle and it went like this, formed by two chords. Then the angle in the middle and the arc had that relationship where the arc was twice as much as the angle. It's the same idea here. This arc here is twice as much as this. Okay, the arc is like 2x. So we're going to use that idea to solve some other problems. So if we look here, it says that arc AC will be 4A, and that's minor arc AC. So minor arc means it's the small one. Okay, the major arc would be the other side. Okay, but the minor arc is the small side, which is 4A. And it says that the major arc AC is 14A. And we want to determine x. So x is formed by the chord and tangent. So we know from what we just did up here that angle x, that right there is going to be half of the arc right here. So it's going to be half of 14A, which means that x is going to be 7A. But we don't know what A is. Okay? Try and think of a way that we can figure out what A is using just this information. Okay? The only other information we know is that we actually have a whole circle made by these two arcs. The major arc, 14A, takes up that much space. The minor arc, 4A, is that much. And when you put them together, you get a full circle. And we know that full circles are 360 degrees. So we can figure out A by saying that 4A and 14A are going to be 360 when you put them together. So that means that we have 18A equals 360, and you divide both sides by 18, and we get A to equal 20. So you could take that and plug it into 7A. So 7 times 20. And we're going to end up getting x to equal 140 degrees. Okay, there's a couple other ways you can do this too. If you wanted to take the 20 and plug that into 14A, okay, then you would get the arc to be 280. And then you can divide that by 2 and get 140. That also works. With these, there's a lot of different ways you can do it because there's a lot of relationships here. But as long as you get this as your answer, then you're good to go. There are some other rules with these too, because sometimes you get, instead of a tangent and a secant, you might have some other combination of them. Okay, so if we look at this rule right here, it says an angle formed by the intersection of two secants, two tangents, or one tangent and one secant is going to be equal to half of the difference of the intercepted arcs. So we've got lots of situations here, and we're going to figure out something else. So if we have this one, this is a secant and a secant. So that is this first one that they're talking about. If we look at the second one, we have a tangent because it crosses once, and a secant because it crosses twice. So that is this piece. And then two tangents is this one. And what's different about this is that for all of those, we get this angle P on the outside. Okay, for this one up here, the angle ended up being right on the circle. But for all of these other ones, the angle goes outside. So that means we have a different relationship here. And I'll show you exactly what our new formula is. Okay. For this, it tells us 3 different formulas. Okay, because we have different points up here. So if we take a look at the actual formula, it says that the angle is equal to half of the difference between the intercepted arcs. So if you look carefully at it, the intercepted arcs that we have, we've got this one, which is the big arc formed out here, minus the small arc formed inside here. And angle P, which is this right here, is going to be half of the big arc minus the little arc. And if we look at the next one, we're actually going to have the exact same thing. Okay, AC is the big arc, and then AB is the little arc. Okay, and it's the arcs that are formed by the 2 lines going through it. Okay, so if you take a look at our lines, we've got a point here, and we've got the points here. For the other one, we had these 2 points and these 2 points. So we're connecting the arcs that are inside this kind of like pizza slice thing in here. Okay? And if we look at the last one, we have our 2 lines, and the big arc is this whole thing, and the little arc is this piece here. Okay, and just to clarify this piece right here, there is a little typo on it. Okay, that says ABC, and ABC would be this. Okay, it should say ACB. Okay, because it starts at A and ends at B, and C is in between. So instead of memorizing all of these different formulas with all the letters, especially when the letters can change, I like to write it like this. Okay, so we have the angle, so that's angle P for all of these, the angle on the outside. The angle on the outside is going to be equal to half of the big arc minus the little arc. Okay, and that's what we're going to do for all of these. Okay, and I've color coded it. So the angle is the green part that I have on the outside. The big arc is the one that's furthest away from the angle. And then the little arc is the one that's closer. And you need to know the vocab words from up here, secant and tangent, because sometimes they don't give you the picture. Like exercise 3, we don't have a picture there. So we're going to start by drawing the picture. It says that we have 2 secants intersecting outside of a circle. So that means we have a circle and we have 2 secant lines. So secants are going to go through the circle twice. So we're going to have something that looks like this. And they meet at a point, and that point is going to have 42 degrees right there. It says the larger of the 2 intercepted arcs, so that means the big one, so that's this right here, is 168. And we want to determine the smaller arc, so that's the little piece, which is here, and we can call that x. So we're going to use the formula that I said before. So we have the angle is half of the big arc minus the little arc. The angle is 42 degrees. That's the one that's on the outside. And then we have the big arc is 168 minus the little arc, which is x. And then we can try and solve for x. Okay, so there's lots of ways you can do that. You can, the way I'm going to do it is I'm going to distribute this 1/2. Okay, so I'm going to have 42 equals half of 168. And then subtract x over 2. And half of 168 is going to be 84, so I'm just going to rewrite that as 84. And then to solve for x, we're going to subtract 84 from both sides. And I'm going to rewrite that over here. So when you subtract 42 minus 84, you're going to get negative 42. And that's going to be equal to negative x over 2. And then I'm going to cross multiply. So we've got negative 1x and negative 84. Divide by negative 1. And we get 84 as our answer. Okay, and there's a whole bunch of ways you can do all of this algebra over here. It doesn't matter to me how you do it. You can do it a whole bunch of different ways. As long as you get 84 as your answer, then you should be good. So exercise 4 is the same idea, except now we have 2 tangents. So that means our circle is going to have 2 tangents. So that means they only cross once at this point and this point. And it says that they meet at an angle, and that angle is 80 degrees. And we need to determine the measure of each intercepted arc. So we need to find both the big arc right here and the little arc right here. And the way I drew my picture, it looks like they're about the same. But remember, you can draw the picture in a whole bunch of different ways. You know, I could have drawn it like this, and the big arc is way bigger than the small arc in that picture. Okay, so we don't know for sure. Just because you draw it a certain way doesn't mean it has to be, 180 if it looks like it's half. So we are going to do the formula to see if we can figure this out. We don't have a whole lot of information, but what we do know is that they're both tangent lines. So that means that when you add the big arc and the small arc together, you're going to get a whole circle, right? If you put the blue and the red arcs together for 2 tangent lines, they're going to equal 360 because it's the whole circle. So what I'm going to do is I'm going to call the small arc x, and then the big arc I'm going to call 360 minus x. Because if I knew what the small arc was and I wanted to find the big arc, I would just subtract from 360. So that's what we're going to do. And we're going to do the same formula again. So we're going to do the angle is half of the big minus the little. Our angle is 80, and that is half of the big, which was 360 minus x, minus the little, so minus the little, and then we're going to solve for x. So we're going to combine like terms. So if we look at the parentheses here, we can do 360 minus 2x now. And we've got the 1/2 and the 80. Okay, and I'm going to do the same thing I did before and distribute the 1/2. So half of 360 is going to be 180, and half of negative 2x is going to be negative 1x. And then if I solve for x, we get this. Okay, so x is 100. We have to check and see if we answered the question. So it says to determine the measure of each intercepted arc. So right now we just did x, which is the little arc. So this is 100. And then to find the rest of the circle, we're going to do 360 minus what we know. And that's going to give us 260. So this piece over here is 260 degrees. Okay, so now we've answered the question. We've done both parts. So these next pieces here is more of the same thing. And what I want you guys to do is I want you to try these on your own. And I'm going to put the answers up on Google Classroom so you can double check. That way you can make sure that you know what you're doing that way. And then you could try out the homework after you've seen that you've done these ones correctly. Okay? If you need help with this, I'll color code it for you. Okay? Because a lot of people like the color coding. So the angle is going to be the part that I put in green before, so I'll rewrite the formula too. So the angle is equal to half of the big, which I've been putting in red, minus the little. Okay, so the angle for all of these is the piece on the outside. The big arc is where you've got your 2 points here and you connect, and that's this. For this one, it's this arc. And for this one, it's this piece. And then the small arc is this piece. Okay, so you're going to take all that and you're going to plug it into this formula. If you're not sure where that information comes from, everything that I just drew on here, then make sure you write me on Google Classroom or something and let me know, because I'll try and explain it to you. You could also come to one of the Zooms on Wednesdays and ask me questions there, and I'll try and explain it to you in person as well. The last thing I wanted to mention for this is for the homework, the first one, it tells you that you have 2 tangents. So that means it's going to look like this, where they both cross at one point right here. And it says that the ratio of the arcs is 7:2. So that's what it's going to look like. You're going to have 7x and 2x. One of the ways that you can think of that is if you had a circle and you cut it into 9 equal pieces, because like we did before with the ratios, if you add the 2 pieces together, that's going to tell you how many equal parts you have. So if you had 9 equal pieces, okay, like that, then 7 of them are going to be for the big arc and 2 of them are going to be for the small arc. Okay, so 1, 2, 3, 4, 5, 6, 7, that's for the big arc, and then the other one has 2 for the small arc. And if they're all exactly the same size, then that means that this one could be 7x. Come on. 7x. There we go. And the other one is 2x. So that's where this came from. Okay, so you could always, whenever you have a ratio, just write 7x and 2x and then put them where they belong on your picture. Okay, so we're going to see a little bit more with ratios in the next couple lessons too. So that's something that will help you out.